Right now, under your feet, the floor of the Pacific Ocean is being eaten. Not eroded, not shifted. Eaten, swallowed whole into the planet at about 7 centimeters every single year. That sounds slow. It is not. It means an area of ocean floor the size of a city block vanishes into the earth every few minutes. The entire ring of fire, every volcano in Japan, Indonesia, Chile, Alaska, is the planet digesting what it swallowed. The largest earthquakes ever recorded, the deadliest tsunamis in human history, all of them happen because the ocean floor is being dragged under. And the deepest place on Earth, the Mariana Trench, is not really a trench at all. It is a mouth. Scientists mapping the seafloor found something that should have shaken everyone. The ocean floor is young. Absurdly young. The continents carry rocks for billion years old. The oldest ocean floor anywhere on Earth is barely 180 million. 95% of every ocean floor that ever existed is gone, devoured. In the next 40 minutes, you will follow one piece of ocean floor from its violent birth to its death, and down to a place 2,900 kilometers below your feet, where scientists found the graveyard of dead oceans. What is buried there has been falling for 200 million years. We will get to it, but first you need to see the crime scene. Here is the fact nobody talks about. The ocean floor should not look the way it looks. The oceans are older than almost everything. Water has covered most of this planet for around 4 billion years. 4 billion years of dust, dead plankton, volcanic ash, and sand drifting down in a slow, endless snowfall. Do the math, and the seafloor should be buried under sediment tens of kilometers thick. A suffocating blanket built up since before complex life existed. But when research ships finally drilled into the deep floor in the 20th century, they found almost nothing. A few hundred meters of sediment. In places, barely enough to bury a house. It was like walking into a house that has stood for 4 billion years and finding no dust on the shelves. Somebody or something was cleaning the floor, erasing it, recycling it faster than the ages could pile up on top of it. The person who found the first real clue was a woman who was not even allowed on the research ships. Marie Tharp, a geologist in the 1950s, was told mapping expeditions were no place for a woman. So she stayed on shore and drew. Sounding by sounding, she turned raw depth numbers from Navy ships into the first true map of the Atlantic floor. And in the middle of her map, something impossible appeared. A mountain range, running down the center of the ocean like a spine, longer than the Andes, the Rockies, and the Himalayas combined. And straight down its crest ran a crack. A rift, splitting the range in two, exactly like the seams on a baseball. When the same spine showed up in the Pacific, the Indian Ocean, the Southern Ocean, 65,000 kilometers of it, wrapping the entire planet, the conclusion became unavoidable. The ocean floor was not a dead surface. It was a conveyor belt, born in one place, destroyed in another endlessly. Her colleague dismissed it as girl talk. Within 15 years, it became the foundation of modern geology, plate tectonics. The proof came from an instrument built to hunt submarines. After the Second World War, survey ships dragging magnetometers across the ocean noticed the seafloor was striped. Bands of rock with normal magnetism, then reversed magnetism, then normal again, running parallel to the mid-ocean ridge like the stripes of a zebra. For years, nobody could explain it. Then someone remembered a strange fact. The Earth's magnetic field flips. Every few 100,000 years, north becomes south. And cooling lava freezes the direction of the field into itself, like a tape recording. Suddenly, the stripes made terrifying sense. The ocean floor was a tape machine. New rock at the ridge records today's field, gets pushed aside, and the next batch records the next flip. Symmetrical stripes, mirrored on both sides of the ridge, because both sides are moving away from it. You could read the seafloor like a barcode and watch the conveyor run. Young rock at the center, older and older toward the edges. The floor really was being made in the middle of the oceans, which left one monstrous question. If new floor is constantly being made and the planet is not getting bigger, where does the old floor go? The answer was hiding in the deepest places on Earth, and it had been staring sailors in the face for a century. So if the floor is a conveyor belt, it has to start somewhere. And you are about to stand in the exact spot where the planet builds new ground. But be warned, the birthplace of the ocean floor is one of the most violent places on Earth. 2.5 kilometers beneath the surface of the eastern Pacific, the planet is tearing itself open. This is the East Pacific Rise. Down here, two tectonic plates are pulling away from each other, and the Earth's molten interior is rushing up to fill the gap. Magma meets near-freezing water and shatters into black glass. Pillow after pillow of new basalt stacks up in the darkness. This is brand new planet minutes old, hot to the touch, hissing as it is born. Every year, along the world's mid-ocean ridges, about 20 cubic kilometers of new ocean floor are created. Enough rock to bury Manhattan under a layer 300 meters thick. Every single year. And around the newborn rock, impossibly, there is life. Towers of mineral chimneys taller than houses, belching black superheated water. 400 degrees Celsius, hot enough to melt lead. Kept liquid only because the pressure will not let it boil. Around them, forests of 2-meter tube worms, blind shrimp in swarms of millions, crabs that farm bacteria on their own shells. An entire ecosystem that has never seen the sun, running not on light but on chemistry. Some scientists believe this is where life itself began, 4 billion years ago, which means the ocean floor is not just ground. It may be the cradle of everything alive, including you. Lower a hydrophone near a mid-ocean ridge and you can hear the planet being born. Pops, groans, long rolling booms as fresh rock cracks and settles. The ridges produce thousands of small earthquakes a day, a constant crackle running down 65,000 kilometers of seam. The quietest place on Earth is also its loudest construction site. We just built our cities too far away to hear it. And the newborn floor is not solid. Drill into it, and kilometer after kilometer comes up riddled with cracks and veins. All of it flooded with seawater, all of it alive. Microbes live inside the rock itself, eating hydrogen and iron, doubling their populations over centuries instead of minutes. By some estimates, the crust beneath the oceans holds a huge share of all the living cells on this planet. A hidden biosphere, sealed in stone, riding the conveyor. Which means what the trenches swallow is not just rock. The planet is eating living tissue, its own. Now pick a spot. 1 single square meter of this newborn black rock. Remember it, because we are going to follow it for the rest of its life. For the next 180 million years, that square meter will crawl across the bottom of the Pacific carried by the conveyor. It will cool. It will sink lower. It will collect the slow snow of the dead. And at the far end of its journey on the western edge of the Pacific, the mouth is already waiting. The trench our square meter is drifting toward existed before dinosaurs. It has been swallowing ocean floor, without pause, for over 100 million years. And here is the number that should genuinely unsettle you. At current speed, the entire Pacific, the largest ocean on this planet, will be gone. Completely closed. Swallowed. The ocean that covers a third of the Earth is not a permanent feature. It is a temporary puddle between collisions, and it is already shrinking. But before the floor can die, it has to live. And its life, the longest commute in the natural world, is stranger than its death. Welcome to the abyssal plain, 4 to 6 kilometers down, the single largest habitat on Earth and the emptiest, Our square meter of floor is a few million years old now. It has cooled, hardened, and started its slow slide west, and onto it falls the snow, marine snow, the remains of everything that dies in the kilometers of water above. Plankton shells, fish scales, the dust of continents blown out to sea. It falls so slowly that a single flake can take weeks to reach the bottom. The plane our square meter crosses is the flattest surface known to exist. Not the flattest on Earth, the flattest anywhere. Some stretches drop less than a meter over 100 kilometers of distance. If you shrank the Earth to the size of a billiard ball, the abyssal plains would be its polish. It is also the coldest long-distance river on the planet. A creeping current of near-freezing water, sunk at the poles, slides across these plains for 1,000 years before it surfaces again. The water touching our square meter tonight last saw the sky before the fall of Rome. And in 2024, instruments sitting on a nodule field recorded something that was not supposed to be possible. Oxygen, appearing in the darkness, with no sunlight and no photosynthesis. Dark oxygen, possibly made by the metallic nodules themselves, acting like natural batteries and splitting seawater. If it holds up, textbooks change. The dead, black, sunless floor may quietly manufacture the gas of life. The place we wrote off as a desert keeps turning out to be a machine. It builds up at about 1 millimeter every 1,000 years. The length of your fingernail every 100,000 years. And yet, given enough time, this snowfall buries mountains. Sometimes something enormous crashes through the snow. A whale carcass lands, and for 50 years an entire ecosystem feeds on it. A single meal that lasts 2 generations. Bones become reefs. Then the snow covers those too. Our patch of floor drifts past drowned volcanoes. Seamounts, over 10,000 of them hidden in the Pacific alone. More mountains than exist on all the continents combined. Some wear crowns of cold water coral older than the Roman Empire. Corals down here grow so slowly that a colony the size of a chair may have been alive when the pyramids were built. In places, the plain is paved with strange black potatoes. Manganese nodules, metallic lumps that grow around a shark tooth or a bone chip, one atomic layer at a time. They grow a few millimeters every million years, among the slowest processes ever measured. A nodule that fits in your palm has been forming since before the Himalayas existed. There are trillions of them, and mining companies are already circling. The slowest treasure on Earth may be spent within a single human generation. Far to the west, our square meter passes the oldest surviving ocean floor on the planet. A patch of the western Pacific near the Mariana Islands, born when dinosaurs were still a new idea. 180 million years old. When that rock erupted at a ridge, the Atlantic Ocean did not exist yet, and the first tiny mammals were hiding between the feet of giants. Everything older than it, every floor of every earlier ocean has already been eaten. And even down here, we have already left our mark. Sediment cores from the deepest plains now carry a thin, unmistakable layer of microplastic and fallout from nuclear tests. The snowfall of the 20th century. Our signature on a page the planet is about to swallow. And here is a thought that should stop you cold. We have mapped less than a quarter of this landscape in any real detail. We have better maps of Mars than of the ground our own ocean sits on. Mars, a planet 200 million kilometers away, is better known to us than the floor of the Pacific. The crawl west takes 180 million years. While our square meter makes its journey, dinosaurs rise and die above it. Mammals inherit the planet. The first humans light the first fires. By the end, the floor is ancient, cold, dense, heavier than the hot mantle rock beneath it, and that is the fatal detail. Because in geology, whatever becomes denser than what lies below it sinks. The ocean floor does not get pushed into the earth. It falls. Ahead of it now, a line in the ocean where the water above suddenly deepens by 7 kilometers. The commute is over. The mouth is open. The Western Pacific. The Mariana Trench, 2,500 kilometers long, and deeper than anything else on the face of this planet. This is where our square meter of ocean floor, 180 million years old veteran of the longest journey on Earth, arrives to die. Take Mount Everest, flip it upside down, and drop it into the trench. Its peak would still be more than 2 kilometers underwater. The Grand Canyon is a scratch by comparison. At the bottom, the pressure is 1,086 times what you feel right now. The weight of 50 jumbo jets, pressing on every square meter. A human body would be compressed in less than a second. Only a handful of humans have ever been down there. The first two, Jacques Picard and Don Walsh in 1960, inside a steel sphere with walls 13 centimeters thick, heard one of their outer window panes crack on the way down. They kept descending anyway. 5 hours down, 20 minutes on the bottom. Picard later said the silence was so complete it felt aggressive, as if the ocean was holding its breath. And in that final darkness, the light caught something impossible. A flat fish calmly swimming over the deepest ground on Earth. Life at the mouth of the underworld. We now know fish live at least to 8,336 meters. A ghost white snailfish filmed in a trench off Japan, deeper than any fish ever recorded. His body has no scales, no pigment, and a skull you can see through. Below that depth, the pressure starts to break the very protein cells are made of. Deeper still, the trench belongs to stranger things. Single cells the size of your fist, sea cucumbers that swim like ghosts, shrimp thriving in water that would crush a submarine from the surface world. An entire hidden ecosystem, living its whole existence on a floor that is actively sliding into the planet beneath it. Every creature down there is a passenger on a sinking ship, and none of them know. And inside those passengers, scientists found something that should embarrass our entire species. They trapped amphipods, small, pale scavengers, at the bottom of the Mariana and Kermadec trenches, 11 kilometers down, and analyzed their tissue. The animals were saturated with industrial pollutants, PCBs, chemicals banned in the 1970s, at concentrations higher than in crabs from the most polluted rivers in China, in the most remote habitat that exists on this planet. On the floor of the Challenger Deep itself, one of the deepest dives ever made found something resting in the sediment at 10,900 meters. A plastic bag. Nothing we make disappears. The marine snow carries our chemistry down into the mouth of the planet, and the trench swallows that too. Millions of years from now, a thin layer of humanity's fingerprints will ride a slab into the mantle and burn. But the trench is not the story. The trench is just the crease, the line where the Pacific plate bends and dives under its neighbor. Geologists call it subduction, the planet swallowing its own skin. Watch what happens to our square meter now. As the plate bends downward, it groans, cracks. Deep parallel fractures split the old basalt as it curves toward the dive. And through those cracks, the ocean pours in. This is the detail almost nobody knows. The dying floor does not go down dry. It drags the ocean itself down with it. 3 billion tons of seawater, every year, locked into the sinking rock and carried into the planet. Multiply that by 100 million years, and you realize the Earth is slowly drinking its own oceans. Some of that water never comes back. The oceans you know are measurably smaller than the oceans of the deep past, and the planet's thirst is not finished. Where all that water ends up, you will see in a few minutes. It is stranger than you think. First, though, you need to understand what happens at the contact line. Because two plates do not slide past each other politely. They stick. for decades, sometimes for centuries. The plunging ocean floor and the plate above it lock together, jammed by friction, while the conveyor keeps pushing from behind. The edge of the upper plate is dragged down and bent, like a diving board slowly loaded with invisible weight. Strain builds for 300 years. The land itself is bent out of shape, storing the energy of millions of atomic bombs. Above it, calm water, fishing boats, cities on the shoreline. Nobody feels a thing. While the plates are locked, something else is happening at the lip of the trench. Not everything goes down the mouth. As the ocean floor dives, the plate above scrapes off its topping, kilometers of soft sediment, peeled away like frosting off a cake. That scraped-off material piles up against the edge of the continent, layer over layer, for millions of years. Entire coastlines are built from it. Large parts of Japan, Alaska, and the Western Americas are not original continent at all. They are the compacted leftovers of eaten ocean floors. Read that again. The ground under cities on the Pacific Rim is partly made of ancient seabeds that never finished being swallowed. The planet eats sloppily. The crumbs became real estate, sometimes a whole seamount. A drowned volcano the size of a mountain range rides the conveyor into the trench and jams sideways in the planet's throat. The locked zone strains around it. Geologists believe these swallowed mountains are what makes some sections stick hardest and snap biggest. And then, on an ordinary afternoon, the lock fails. March 11th, 2011. 2:46 in the afternoon, Japan time. 80 kilometers off the coast of Tohoku, the locked edge of the Pacific floor finally tears loose. A section of sea floor the size of a small country lurches 50 meters westward in under 3 minutes, and the edge of Japan's plate, bent downward for 3 centuries, snaps back up like a released diving board. It throws the entire column of ocean above it, 7 kilometers of water, upward. That bulge becomes a wave. The wave becomes the Tohoku tsunami, magnitude 9.1, the 4th most powerful earthquake ever measured. The planet rang like a bell for weeks. The day itself became measurably shorter. The quake shifted so much mass that Earth now spins very slightly faster. Nearly 20,000 people never saw the evening, and the force that killed them was not weather, not chance. It was the ocean floor, being eaten, fighting back on its way down. Look at the 3 most powerful earthquakes in recorded history. Chile, Alaska, Japan. All 3 happened at subduction zones. Every earthquake above magnitude 9 that humanity has ever measured came from the same crime. Ocean floor being swallowed. And sometimes the floor leaves evidence that takes centuries to decode. In January 1700, villages along the coast of Japan were hit by a tsunami that arrived out of nowhere. No earthquake, no warning. They called it the orphan tsunami, a wave with no parent. Magistrates wrote it down. The flooded rice stores, the ruined salt kills, the hour the water came. Then the mystery sat in the archives for 300 years. The answer was on the other side of the Pacific. In Washington state, scientists found ghost forests. Entire stands of cedar killed in a single moment when the coastline suddenly dropped and salt water flooded in. Tree rings gave the death date, the winter of 1699 to 1700. Put together, the evidence reconstructed a monster. On January 26, 1700, around 9 in the evening, the Cascadia subduction zone, off Seattle, Portland, Vancouver, ruptured in a magnitude 9 earthquake. The orphan's parent was found, 10 hours ahead of the wave that hit Japan. Here is why that matters tonight. Cascadia is locked again. It has been storing energy for over 300 years. The same silent, bent diving board loading you just watched. The floor off the American Northwest coast is being eaten, the lock is jammed, and the geological record says it lets go, on average, every few centuries. The next magnitude 9 on this planet is not a question of if. It is a schedule we cannot read yet. Meanwhile, our square meter has already passed the point of no return. It is inside the planet now, and its descent is just beginning. It slides down at an angle, a stiff slab of cold rock knifing into mantle that glows like coal. 30 kilometers down, 50, 100. The pressure rewrites its chemistry. Minerals collapse into denser forms. Basalt becomes eclogite, a rock so heavy it pulls the whole slab downward faster, like a swimmer whose clothes have turned to stone. And now the water gets its revenge. All that seawater locked in the cracks? 100 kilometers down. The heat wrings it out of the rock like a sponge. Water lowers the melting point of everything it touches. The mantle above the slab begins to melt. That melt rises, and where it reaches the surface, Japan happens. Indonesia happens. The Andes happen. 452 volcanoes in a horseshoe around the Pacific. The Ring of Fire. Every one of them is a chimney venting the digestion of the ocean floor. Mount Fuji is made of recycled Pacific. The ash that buried Pompeii was once the bottom of a sea. And the stolen water explains one of volcanology's oldest puzzles. Why some volcanoes pour and others detonate. In Hawaii, tourists stand a few hundred meters from rivers of lava. Nobody would dare do that in Indonesia. The difference is the ocean floor. Subduction magma is loaded with the seawater it swallowed, and dissolved water in magma behaves exactly like the gas in a shaken bottle of soda. Near the surface, the pressure drops, the water flashes to steam, and the mountain becomes a bomb. In 1883, one of those bombs, Krakatoa, sitting above the swallowed floor of the Indian Ocean, exploded with the loudest sound in recorded history. It was heard as sound 5,000 kilometers away. Sailors 40 kilometers from the blast had their eardrums ruptured. The shock wave circled the planet 4 times. For months afterward, sunsets across the world burned so violently red that fire brigades in New York were called out to horizons that were not burning. That color was the ocean floor, vaporized, thrown into the stratosphere, and painted across the sky of every country on Earth. Every one of those catastrophes is the final receipt for a piece of seafloor that began its journey at a ridge 100 million years earlier. The explosion is the last thing the eaten floor ever says. When those volcanoes erupt, they exhale the ocean's stolen water back into the sky as steam. Some of it rains back into the sea, a round trip of 100 million years. But not all of it comes home. Deep in the mantle, water gets trapped inside a crystal called ringwoodite and stays 600 kilometers beneath your feet, locked inside solid rock. There is more water than in every ocean on the surface combined. A hidden ocean, fed for billions of years by the eaten seafloor. The planet is not just swallowing its skin. It is hoarding its oceans. For decades, that hidden ocean was just theory until the planet mailed us a sample. In 2014, researchers examining a cheap, battered diamond from a Brazilian riverbed found a microscopic crystal trapped inside it. Ringwoodite. Real ringwoodite from 600 kilometers down, and it was wet. Diamonds are time capsules. They form in the deep mantle and rocket to the surface in volcanic eruptions, sealing whatever they capture inside the hardest container in nature. This one carried a drop of the hidden ocean, physical proof that the water is really down there. Even stranger, the world's most famous blue diamonds, the color of the Hope Diamond, get their tint from boron, an element that belongs in seawater. They formed deeper than almost any other diamond. The stones in those museum cases are very likely pieces of eaten ocean floor, returned to the surface wearing the color of the sea they used to be. Kings and billionaires have been collecting the ghosts of dead seafloors without knowing it. And our square meter keeps falling. 200 kilometers. 400. 660. Where the mantle stiffens and some slabs stall and pile up like traffic. Earthquakes still crackle through it 700 kilometers underground. The deepest earthquakes on Earth happen inside these dying slabs, in rock that should be too hot and too soft to break at all. In 1994, one of them, 630 kilometers beneath Bolivia, reached magnitude 8.2 and shook buildings from La Paz to Toronto. An earthquake born deeper below the surface than the space station flies above it. Scientists still argue about how rock that deep can snap at all. The leading suspect, the dying slab's own minerals, collapsing into denser forms in sudden, catastrophic bursts. The eaten floor does not go quietly. It screams all the way down. Then, below 700 kilometers, silence. No more earthquakes, no more signals. For decades, scientists simply lost track of the slabs there. The eaten ocean floor vanished from every instrument. Where does it all go? An entire planet's worth of vanished seafloors, 5 oceans out of every 100 remaining, had to be somewhere. The answer was found at the very bottom of the mantle. And it is the most haunting image in modern geology. To find the missing seafloors, scientists turned the Earth itself into a patient on an operating table. The technique is called seismic tomography, literally a CT scan of the planet. Every large earthquake sends waves through the entire globe, and those waves travel faster through cold rock than through hot. Record enough earthquakes from enough stations, and you can build a three-dimensional image of everything inside the Earth, the way a hospital scanner sees a tumor without a single incision. When the first full planet scans came into focus in the 1990s, geologists saw shapes in the deep mantle that made the room go quiet. Slabs, enormous, cold, curtain-shaped shadows, hanging in the mantle like sheets of ice in dark water, thousands of kilometers long, plunging all the way down. They were looking at the dead. Every cold shadow was an ocean floor, swallowed millions of years ago, still falling in slow motion toward the core. At 2,900 kilometers, the boundary where rock meets the molten iron core, the falling ends. The slabs pile onto each other in drifts. Geologists gave the place a name that belongs in mythology: the slab graveyard. The scans found something else down there. 2 colossal shapes that are not slabs at all, continent-sized masses of something hotter and heavier, one under Africa, one under the Pacific, each the size of a planet's worth of mystery. Some geologists now suspect they are not from Earth at all, that they are buried pieces of Theia, the Mars-sized world that slammed into the young Earth 4.5 billion years ago and threw off the debris that became the Moon. If that is true, then the ocean floors are falling onto the wreckage of another planet, and every night its other half rises over the horizon as the Moon. The graveyard at the bottom of the mantle may be a crash site, and the graves have names. Under North America hangs the Farallon Plate, an ocean floor that once rivaled the Pacific. It began dying when Tyrannosaurus was alive. It is still down there, still sinking, 100 million years into its own funeral. Under Europe and Asia lie the remains of Tethys, the tropical ocean that dinosaurs swam in. When it was eaten, India slammed into Asia, and the collision pushed up a tombstone 8 kilometers high. You know it as the Himalayas. Seashells are found near the summit of Everest. The roof of the world is the floor of a murdered ocean. But the graveyard is not the end of the story, because down at the core boundary, the dead do not rest. Heat from the core slowly cooks the buried slabs. And in places, plumes of that reheated rock rise all the way back, punching through the mantle like smoke through water. Where a plume reaches the surface, islands are born. Hawaii, Iceland, The Galapagos. Parts of those islands may literally be resurrected ocean floor. Seabeds that died before the dinosaurs return to the surface after a journey of hundreds of millions of years. Walk on a black sand beach in Hawaii, and you may be standing on the reincarnation of a floor that once lay under an ocean no human ever saw. The planet does not just eat its oceans. It digests them and builds new worlds from the remains. So what happens next? Because the eating has not stopped. It is happening right now at this exact second along 55,000 kilometers of trenches. The Pacific plate moves at 7 centimeters a year, twice the speed your fingernails grow. The fastest plates in Earth's history hit 24. These are not geological abstractions. You could watch a plate move with a ruler and a decade of patience. GPS satellites measure it live. Hawaii drifts toward Japan by the width of a hand every year. Australia moves so fast that its official map coordinates had to be corrected. The whole continent had crawled out from under its own maps. We are even starting to hear the eating in real time. Seismic stations and seafloor cables around the Pacific now pick up something discovered only in the year 2000. Slow slip earthquakes. Silent ones. A patch of locked subduction zone the size of a country lets go. But instead of 3 minutes of violence, the slip takes weeks. Energy equal to a magnitude 7 earthquake is released, and nobody on the surface feels anything at all. The ground under entire cities glides several centimeters. In silence. Cascadia produces one of these silent events roughly every 14 months. Like a slow heartbeat. Each one transfers a little more stress onto the locked zone offshore. Scientists watch them the way cardiologists watch an arrhythmia, because one day one of those silent slips may be the trigger. The planet is not just eating the floor. It is doing most of the chewing where no one can feel it. Here is the twist almost nobody sees coming. The Atlantic, the ocean that is currently growing, has already been infected. Beneath the Strait of Gibraltar, a subduction zone from the dying Mediterranean is slowly invading the Atlantic. Geologists watched the scans and realized the Atlantic's death has already been scheduled. The mouth that will eventually eat it is forming now. Oceans, it turns out, have a life cycle as predictable as the stars. They open, they widen, they age. A trench forms at their edge, and from that moment they are terminal. Run the conveyor forward 250 million years, and the supercomputers all draw versions of the same picture. The Pacific closes. The Americas dock against Asia. Every major landmass fuses into one. A supercontinent geologists have already named Amasia. One continent, one world ocean around it. The center of Amasia will be a desert larger than anything Earth has ever carried, thousands of kilometers from the nearest coast. The first casualty is already chosen. The Mediterranean, the Sea of Rome, Carthage, and Alexandria, is a shrinking sliver of a dying ocean, caught between Africa and Europe as they close like a vice at the speed of a growing fingernail. When its last floor is eaten, the two continents will collide, and a mountain wall will rise across southern Europe. A second Himalaya, standing where beaches full of tourists are tonight. Every wave breaking on a Greek island is breaking over a countdown. And then the cycle will turn again. Amasia will crack. New ridges will open. New oceans will be born in fire, crawl for 100 million years, and be eaten in their turn. Our square meter of floor, the one born at the East Pacific rise, is deep in the mantle now. In 250 million years, some of its atoms may ride a plume back up and glow in the lava of a volcano that does not exist yet, on a continent that has no name. Stand on any shoreline tonight and you are standing on borrowed ground, between a floor that is dying in the west and a floor being born in the east. The tide comes in over a surface that is itself a wave, one that takes 200 million years to break. The Earth is not a rock with water on it. It is an engine swallowing oceans, burning them, breathing them back out through volcanoes. Every mountain is a receipt. Every earthquake is a heartbeat. And the floor of the sea, the quietest, darkest, least visited place there is, turns out to be the most alive thing on the planet. Not alive like a creature, alive like a fire. The ocean floor is being eaten. It always has been. And without that hunger, there would be no volcanoes, no continents, no Himalayas, very possibly no life at all. The next time someone tells you the ground beneath your feet is solid and permanent, you will know the truth. You live on the thin, moving skin of something alive in slow motion. A planet that is still chewing, still swallowing, still digesting the last 5 oceans it ate. If this journey changed the way you see the ground you stand on, the next one goes deeper still. Because the creature that lives further down than anything else on Earth has a story of its own.